And so from we were doing an Ask the Experts, and I know there's probably a lot of experts already in the room, but for the thermal bridging at the edge of opaque panels, we have Stephane Hoffman from Morrison Hershfield, who's done much work in this area, and from Technoform, William Green, who is a product manager focused on thermally broken cladding clips, and then our expert on polyamide thermal breaks and polyamide materials is Stephen Aki. I guess I would maybe just to start off here, I'd ask Stephane, can you just tell us what the issues are with the panel attachments and how much degradation you can really get from what should be a really good panel performance if you don't attach it correctly?
I mean, what we've seen is that you can have significant loss in the value of your continuous insulation if the attachments that bring the panel back to the base structure provide significant thermal breaks. Like if you have, like we did not long ago, continuous Z girds running either horizontally or vertically back to the structure, the amount of thermal bridging that you had could, reduce the value of that insulation by 50% or more, depending on kind of your spacing. And so increasingly people have gone to kind of intermittent attachment systems that kind of provide a discrete connection between a horizontal rail outboard of the continuous insulation back to the structure in an effort to improve that thermal performance. And that can significantly reduce the loss down to as little as kind of 10 to 20%. So the performance increase is significant.
So what are the kind of strategies that you're using to eliminate that?
Well, the first strategy is to first move away from continuous elements that create a thermal bridge. If you're going to continuous element, making it out of a kind of non-conductive material, such as the green girt systems, or more commonly to going to a discrete attachment, point attachment type of clip, and going then from that perspective of designing your clip from a kind of discrete continuous element. A few years ago we would do them just out of intermittent Z girds, to now much more sophisticated systems that either use a kind of thermal break in the clip system to separate the part of the clip that's outboard of the insulation that receives the continuous rail, or clips that are made of a non-combustible material that is non-conductive, so that you can have a continuous piece that goes directly through but has really low thermal conductance.
If I can chime in here, do you guys have like a size matrix for panel sizing? And because I'm assuming when you go down to this alternate material clips that you're obviously limited size-wise and load-wise with those panels. Do you guys market that and present that, or are you not limited at all? Are they just?
Yes, for several of the manufacturers whose clip systems we have analyzed, we've created load charge tables that kind of shows you kind of how frequently you have to have the clip attachments to kind of take the load of the continuous rail back to the backup structure. It's an important aspect because some clip systems may have great thermal performance, but not be really good from a structural perspective, or I should say really good, but have lesser structural capacity. So you could have a system that may be better from a thermal perspective, but you need more of those clips. And overall, that means that the effective U factor is not as good as perhaps a clip that has a stronger structural connection. It may not be as good thermally, but you need fewer of them. So when you're looking at the efficiencies of clips, you really have to balance out the thermal performance with the structural performance and decide, how many clips will be required from a structural perspective and what provides you the best thermal performance.
William, how do you go about, how would you best go about specifying those clips from your perspective to maybe help Daniel with that question?
Yeah, I think well too, there's each individual system has spec language that appropriately addresses some of the issues that we're talking about. But in general, you have your, I think it's exactly what Stephane has said. You have to really evaluate the structural load data, and you have to overlay that with your thermal performance data to make sure you make the best decision for your particular project.
That's clear as water. Thanks, guys.
So how would you compare the different solutions when you're comparing them? What's the best way to compare relative to condensation resistance?
Well, usually in the thermal analysis, you'll have a kind of temperature index that's generated that shows the temperature index at the inside face of the stud, assuming it's a stud system that we're attaching into. And so at that inside point is usually the weakest point in a continuous insulation systems with discontinuous clips. And so on the basis of that temperature index, knowing the exterior and interior temperature, you can generally kind of come up with the surface condition at that point and compare that to your dew point, and then know if that's a risk of condensation.
Daniel, from your perspective, have you ever specified these thermally broken cladding clips for your systems?
No, I was usually a little bit more on the front end, but we definitely would recommend them for our production teams later down the road. And we did do product research, but in the end of the day, I was never involved in these sort of data overlaying tests that you guys are talking about. I was always more just looking through product guides, figuring out something that fit. I was more on the tectonic side of things and just making sure everything was, able to, installation processes was more something that I was concerned about. And we would make recommendations as part of a pre-sale team and as part of a, schematic team for our production teams down the road, but I wasn't as involved. I wanted to be.
On the specification side, that is kind of what we do as facade consultants. One issue that we have is that we typically, when we are in the construction documents or earlier phases of design, we look for a system that meets the structural performance and the thermal performance, so we may put that in the specs. But then it's hard to put a thermal performance in these systems because it depends. I mean, first, we don't know what the spacing of these brackets are gonna be. We also typically, for code compliance, we include all the interior assembly. There is a stud with additional insulation and stuff, so we kind of have to almost separate the exterior part of the cladding or the cladding, the facade side out of the air barrier and kind of put a performance to that we can put in the specs in case the contractor wants to choose a different product than what we specify. So that's kind of the challenge that we see.
Stephane, do you have any recommendations for how to specify the thermal performance?
Usually, what we've done is specified a clear field value. It's essentially the performance of the wall away from any interfaces. And based on kind of spacing, you can determine if a specific clip meets that effective value for the thickness of insulation that you have. That can be your basis of design. And then any substitution then has to show through that kind of modeling that they meet that clear field value. We've had it when we've worked with contractor on projects where the architect has specified a effective or clear field value for the opaque wall assembly, to then work with them to determine for proposed configurations of clips and rails whether that meets that effective U value.
So this clear field value includes the any interior insulation, for example, if there is interior insulation.
Correct.
So,
it includes everything from the interior finish to the exterior, anything that kind of goes through the insulation. If your horizontal rails are completely mounted outboard of the insulation, or if they penetrate the insulation, that's all kind of factored into it. The building envelope thermal bridging guide that was initially published by BC Hydro is now published by BC Housing, has a number of these models that shows kind of durations of wall assemblies with different types of clip, everything from just a discontinuous metal Z-girt to kind of a number of proprietary systems. And also many of the manufacturers have now kind of done that kind of type of study and have posted it to their websites. That gives you the clear field values, and does so with load tables so that you can figure out how many clips at what spacing, and then having figured out the structural aspect, it will give you the U value. So we've done that for a number of manufacturers and stuff on their websites.
So talking about, oh, sorry, Antonio, go ahead.
No, I just said thank you.
Talking about the thermal bridging guide, Stephane, how would somebody use that? Is it pretty straightforward? If somebody wanted to figure out a solution to improve panel performance, and they wanted to look at different solutions, how would they choose? How would they use it to make product selections? And is it enough on its own, or do they have to use other sources, like to understand installed cost and things like that to make a decision?
The thermal bridging guide is a series of assemblies that have been modeled in 3D to provide effective clear field values along with linear transmittance at interfaces. And it gives you a range of assemblies that you can look at. And it's kind of a two-part. One describes the nature model with all the thermal properties, the dimensions, and everything else. And then the second part gives you the thermal results, usually for various levels of different insulations, whether it incorporates the linear transmittance or not, and will give you the temperature index so that if you're understanding kind of a condensation concern, you can evaluate the condensation potential at that interface. What we see a lot of designers doing, especially in BC with the STEP code, and in Toronto, the new green standard that the city has adopted, they are kind of using these to get effective U values for their opaque and clear wall assemblies and putting that into their energy modeling. So that's a way of kind of finding out what systems can meet those. And we're seeing increasingly, more assemblies added to the guide. The latest version is just out. I'll post a link to the chat. But it includes everything from residential wood frame to kind of high-rise construction. It has new mass timber details. The advent of the low Teddy guide has also added, passive house level systems in there. So it's a broad range of systems. And then, from there, if you find something that is suitable for the project, you're looking for a different manufacturer, you can reach out to that manufacturer. Not all manufacturers for whom we've done 3D thermal modeling have elected to post their systems to the guide, but a number of them have these types of reports available. And it's a concept that's also widely available in Europe, the concept of linear transmittance. So if you're looking at European systems, many of them also have this type of information.
William, just a quick question for you. From the work that you've done on comparing the practicalities of using such clips, in terms of total installed cost as well as thermal performance, what are the key pieces that somebody who's specifying this this type of attachment should be aware of?
I think the key is just more or less the installation steps. You know, ease of assembly it's one of those things that it's really important when you get down to the general contractor. I've certainly participated in a study on different types of systems, and you know what it comes down to is just being able to understand the amount of steps that it takes for each solution. So again, it's a situation where you can have certain solutions that might perform better than others thermally, structurally. That I call it that third dimension is how quickly you can get it done in the job. Definitely all three of those contribute to what I would think would be the overall value for the particular clip system or whatever system that you decide to use to make it the most effective one.
I think one thing that we've taken into our practice is at the beginning when we're just trying to estimate overall thermal performance for the wall, we just use 80–90% reduction across a general U value for the assembly without having to go into the envelope enclosure guide that's been mentioned. And then, but one aspect that we've found it has a deep impact is actually the penetrations, the screw points and how it's penetrating and how it's penetrating into the structure. If you're using a sheet metal air barrier as your backing structure, or that's for the facade, what are you doing to ensure that the contractor is actually making seals at those points? And that it triggers a lot of things in terms of maybe even getting a potential blower door test when the enclosure is complete. Stephane, I had a question about kind of linear performance ratings and such. And I've run into this on past projects where you go to a European curtain wall manufacturer and they specify a frame U value of a certain amount. And then you have a North American one, which specifies a certain amount, which is generally going to be a little poorer performing. As I understand it, there's a different kind of methodology for calculating those linear performance on a curtain wall mullion. But do you think that knowledge is known?
I think that right now, you know, the vast majority of the industry is still kind of looking at these elements in isolation. You know, so they'll look at the performance of the curtain wall, they'll look at the performance of the opaque wall, but they don't really kind of put a lot of emphasis on what's happening at that interface. And that's where that linear transmittance concept comes in, is to say, I can have a very effective window, I can have a very effective wall, but at that interface, you know, the window is going to impact the performance of the wall. By how much? Well, that's the concept of linear transmittance. It's the additional amount of heat loss that happens at that interface. That can be a window interface, that could be your floor slab kind of interface, that can be a parapet, and kind of factoring those will impact how much the opaque wall, which tends to be the higher thermal performing system, will be impacted. Because what happens at that interface is that there's additional heat loss where one system impacts another. And where we've seen it the most in kind of glazing systems is when you have full height unitized systems and the continuous vertical runs through from the vision area into the opaque area. And that has a significant impact on the thermal performance of the spandrel panels.
Yeah, definitely.
Antonio, can I ask you a question?
Okay.
You had the very first question you had asked in terms of how do you evaluating the, you know, making that decision in terms of, you know, you're trying to figure out how to get or specify that right solution for you in terms of, you know, thermal performance, structural data. What I was just kind of curious, how are you going about doing that today? I mean, how are you addressing that today?
I mean, we typically, I mean, there are a lot of products that are available here we work in New York City mainly. So we have looked into products that contractors tend to like, because we don't want to, you know, we don't want to specify products that are not economic and that they are not easy to install or something. So we kind of use the feedback that we get from the installers, and we look into those projects, those products. We like aluminum in general more than, I mean, there are some products that are galvanized steel, for example. So we tend to like aluminum more. And then we just typically list, we go, there are some products that are, as you guys are saying, they have in the websites, they have, some of the thermal performance, the structural. So we tend to specify those that we have information that we know why we are specifying these values. And then if the contractor comes back with another product, we can justify where we got our values from. So kind of like having, information about, structural and thermal information, and then kind of having some track record or products that installers like using.
So you use, okay, yeah, that's interesting. That's good though. You're using your contractors to kind of help you to help make that value add.
Yeah, we feel like, if there's something that they like using, it's because it's probably cheaper and easier to install. So I use that as a base to kind of start, if those products work from a performance point of view, I think they are good for everybody and for our clients at the end, I think.
Okay.
So, I mean, I guess typically when you have to go to clip systems that are thermally broken, you have to go to using non-metal materials, generally some kind of thermoplastic of types. And we have an expert on polyamide here. And Stephen, I wondered if you could comment on some of the differences between, say, fiberglass and polyamide in terms of material choices. To think about when you're not just thinking about thermal performance, but actually installation and structural performance.
Sure. Fiberglass is a great product. It's been around for a long time. The issue with fiberglass mainly is the fibers themselves and the lack of ability to machine or produce them. So you're using very, very specified, diamond tip blades that wear out rather quickly because of cutting fiberglass in general is pretty hard on equipment. It's also hazardous for your employees. You have to have them wear some kind of PPE because the fibers tend to get, in the air, on their skin, breathing it in, that sort of thing. So there are those sort of negatives, of that product. The positive is that it's pretty structural, and it has fairly good thermal performance. With the polyamide that we have, which is typically, either 25% or 40% glass fiber, we use sort of a pellet form of glass fiber that actually doesn't come in long strands, so you can cut it with a standard blade, and you don't actually have to have any PPE material on you to help to reduce any kind of risk of getting it on your skin or in your lungs. So that's with regards to thermal, they're both fairly comparable. The issue typically comes with structural, and what you have to do. And we've kind of designed our products with more glass and more sort of geometry, hollows and things like that, to help compensate for the differentiation in the structural components between the two. So when it comes to using fiberglass, it's definitely a product that is used, but we hear a lot of complaints from the manufacturers that have to work with it, and that's where we've tried to design our product to work a little bit better. So I think from a manufacturability and from a ease of use, polyamide is a little bit easier, but then you trade off a little bit on the thermal because you're using more material to compensate. So it really just depends on what you're using it for and where it's going in. That's where you really need to make the determination of what product you can use, what material works best for your situation.
Thanks, Stephen. Are there any questions or discussion points?
I got one question.
Oh, cool.
Do you guys ever use hybrid clips where you have metal on cold side, metal on warm side, but then you just have like somewhere between interfacing between the clips, some sort of sheet of polyamide or something like that, or fiberglass? Do you ever use, you kind of know what I'm saying? Some sort of interface like that between hot and cold metal?
So with the clip that we we use is basically we call it almost a hybrid clip. It has the polyamide, but it also has aluminum. So that's a hybrid as what we've used at Technoform. We have not done anything with the fiberglass. We specialize in more in the polyamide type of that's our main substrate.
Cool, that's awesome.
We can get you some details after if that's of interest.
I love details. That'd be wonderful.
Absolutely.
Doug, I see you're tuned in from California, and as an academic, is there anything from a student perspective, any questions or things that you guys need to know?
I regret to tell you that, in fact, I am tuning in from Southern California, where I can't get my students to pay attention to facade thermal bridging issues because the doors of our buildings are open 24 hours a day, all year long. And so you have all seen the effect of Southern California educated architects trying to do work in places where it might rain or do other weird things that we're not used to. So I am fascinated to learn more about thermal bridging. We do talk about it, but our students have really very little understanding of those kinds of issues. Yeah, it's probably 72 inside my apartment right now. It's 72 outside my apartment right now. I live on the 17th floor and have a glass sliding door. It's open. It's thermal bridging. Sorry, all of you.
Bad for you.
It's a Southern California conceit, but it turns out to be true a lot.
You need to come and spend some time in Ohio.
Coldest place I ever lived was San Francisco.
You've been spoiled, Doug.
There's a great Mark Twain quote about that, though. He said the coldest winter he ever spent was a summer in San Francisco. San Francisco can be cold, but not LA. Thank you for teaching me about thermal bridging. I really appreciate it. Thank you to the panel. Well,
if you need anyone to come and support your teaching your class about thermal bridging, I'm sure we could figure out how to do that.
We will do that. I think you may learn in a few hours that USC, the University of Southern California, is probably going to call off in-person everything. I'm expecting that announcement. In fact, I'll have to drift out in a minute. The president is coming, the university president is coming online. Looks like we're going to call it.
So you could teach from anywhere.
That's a big advantage. Online-edness has been great. I don't want to divert us from thermal bridging, but if anybody wants to talk about the advantages of online learning, when we go back to normal, it won't be normal, it'll be mixed.
Interesting. So any other kind of burning questions on thermal bridging? I see that Stephane had to leave us because he has to go to he's presenting immediately after. So he had to leave us to get prepared for that. So I appreciate his ability to come in, and he's also on vacation this week too. Antonio, from your perspective, you know, do you have any other questions?
One other topic. I mean, I mentioned aluminum before. Obviously, it's not any continuous aluminum girts or anything like that. We don't do that anymore here in New York City or anywhere where it's cold. It was more kind of like isolated brackets and things like that that we see mainly for. I mean, we work in tall buildings, range screens. We see up to 20, maybe 25 stories. Kind of thing. So some of the fiberglass and some of those products are not able to take the windows that we need, or at least with the products that I'm aware of. So that's why we typically go with metal because of structural reasons. Also, kind of tolerances and being able to accommodate tolerances is very important. A lot of the products rely on like shimming, which can get you only up to a certain point, especially if you use like regular screws. You probably don't want to go more than maybe half an inch or so. I don't know, you cannot really take a lot of load in shear if you're shimming like 1 inch or more. So some of the systems that are able to kind of, that don't use as much shimming and kind of use more like an overlap of the parts tend to work better for installation. And when you work in like very tall buildings and in New York City, probably, you know, everybody says that about where they live, that the tolerances are really, really bad. So you kind of have to be able to accommodate as much as possible so the installation can go fast. So yeah, I think tolerance is something that's very important too when we look at this type of products.
And shimming is a, oh, pardon me.
I was just going to ask, what kind of loads do you see?
Yeah.
For wind, we see buildings up to, I don't know, 20, between 20, 25 floors is usually the highest that we see a rain screen system to be feasible. If we go to unitized curtain wall, on rain screens, we probably see up to maybe 60 PSF or so.
60.
On curtain walls, we see up to close to 100 or kind of, but typically we don't see this kind of brackets being used in curtain wall systems as much. But
right.
we actually, and my colleague Mike and I are presenting next Wednesday about thin veneers on curtain wall systems, and now we're seeing more like thin veneers like GFRC or USPC or porcelain and stuff being used on curtain walls, and how maybe these bracket systems would be a good support system for thin veneers as well. We typically use them more in rain screen systems, but we probably are gonna start seeing them more in unitized curtain walls as well.
You say you like using a lot of metal because of the structural. Typically the metal just because of that reason, and how would you address the thermal bridging issue if you're using a lot of metal? Yeah,
well, there are products, there are manufacturers. I don't know if we want to get into specific products, but
sure.
Yeah, there is Envelope, for example, or some other. There is a lot of products that use aluminum systems that are maybe like an L bracket that just kind of connects. It has like a shim, like a thermal shim at the base. It kind of, it's an isolated connection, so it's not. It doesn't seem to have a big impact. I think we see about a 20% R value loss usually with these systems, which seems to be okay. I don't know. Usually these systems have like some sort of plastic base that the aluminum goes to, but the aluminum or steel, galvanized steel, usually kind of bypasses the insulation. So at that point, the thermal shim is not doing much, but it's doing something, I guess.
Yep.
So Daniel, did I interrupted you earlier?
I don't remember what I was going to say then, but now I'm wondering if you guys have wind load optimization, and if you guys change your system depending on the area of wind loads, and maybe if you're using, because I know it's usually like that top back corner on the leeward side of a building where you get the greatest negative pressures, and do you guys just overcompensate for the rest of the building just to meet those loads at that worst case scenario, or do you guys ever maybe change your clipping system or have less clips in other areas, or is it? Yeah, that's my question.
Is it a question to me or is it a question to Anthony?
And
I guess either. Has anyone ever done anything with that? Has anyone ever optimized clipping and panel systems?
Yeah. For us, we see, we're a facade consultant, so we don't do the actual final engineering stuff, but we see that the spacing of the clips gets closer, typically, maybe for this. We typically see the same system being used throughout. We don't see
Right.
contractors changing systems, you know, at the base of the building or at the top. We cannot see the same thing throughout. And then it's more about kind of at the corners using something a little more closer spacing as needed.
Yeah, that makes sense. That seems like the path of least resistance.
Yeah, usually also like the, you know, we follow for rain screen systems, we follow a AAC7 load. So it's more like a block of like, you know, wind loads, the corner and the, you know, the field and the corner. So it's not like when we do a wind tunnel test on a very tall curtain wall system where we try to be more specialized about, you know, the loads that we have here. We basically have like two zones and, you know, the corner and the field. So it's not a lot. I mean, like we also don't want to be like too, like, you know, we don't want the spacing and the systems to be too confusing where like you're going to have issues during installation and stuff. So we kind of want everything to be pretty straightforward.
Yeah, that makes sense.
Yeah.
Well, it looks like we hit time, right? I think we're the next sessions are just about to I think just about to start. I think we were only on for 45 minutes, I believe.
That's correct. Yep.
Yeah. So I think we will get, if we don't cut ourselves off, we will get cut off in a few minutes. But I want to say thank you very much for everybody participating. It was really good to meet you all. And we'll follow up if you want some additional information. And Stephane obviously had to step away, but he's available to answer any questions. He's really the thermal bridging expert. So thank you again, and we look forward to seeing you at the rest of the event. We have the virtual expo happening right now. There's more papers this afternoon. There's also a poster gallery, and we will be presenting as Technoform in 2 weeks' time on the 19th about U-factor in hot climates, why you should care. So Doug, even in LA, maybe.
I care. I was here. You see me. I'm here. Thank you, William, Stephen. Thank you so much. Daniel, good to see you. I haven't seen you in quite a while, so good to see you. I don't know where you are, but I haven't seen
Good
you
to
here.
see you too, Doug.
I haven't seen anybody here, but I haven't seen you here in LA. So thank you all very much for doing this. And I apologize for being a weather arrogant.
We'll look forward to seeing you in person.
Pollution. Don't forget, I got negatives, right?
Probably not so much now, though.
Surprisingly, I had to go out. We're working out this project at Clark Pacific, that UHPC thing, and I've been driving out there, and you'd be surprised how many people are out and about in LA. Yeah, we're idiots.
Okay. Oh, well, as I said in the last session, put your sweater on, put your mask on.
Thank you all.
All right, thank you.
Yeah, everybody.
Thanks, everybody.
Nice meeting
Thank you,
everyone.
everybody. Good to meet you.
Thank
Bye-bye.
you. Bye.